So final week, once again. And before we start, as always, even in my classroom, I always start with a quote: start strong, stay strong, and finish strong, by always remembering why you are doing it in the first place. This
Good one.
is one of the things that I've been using as my focus. Always remember why you're doing things, or whatever it is that you're doing, not just in school, but in real life, outside classroom, outside, anywhere you go. So it's Memorial Day, May 25th. Please remember and honor our fallen, and remember the great sacrifice that they've done for us to make our country great, and of course deserve the freedom that we are experiencing now.
Yeah, something I always remember was that people would say, freedom isn't free. And although we experience this freedom costs some men and women not only their time, their talents, but for Memorial Day, we honor those who their lives were the price of our freedom. So we appreciate their sacrifice, and we want to honor that by living lives that are awesome and great and to the fullest, but to remember that it did cost some individuals the ultimate sacrifice of their life that they laid down freely for us to enjoy the freedoms and the liberties that we have today.
And shout out to my husband. I thank him for his service, for going on a tour in Iraq, and I appreciate all his sacrifice.
Yes, and shout out to my husband also. I appreciate his sacrifice in other ways.
That being said, we're going to get going with this last lesson. Unfortunately, we are going recorded for this week because we wanted to remember our great men and women who sacrificed their lives for our freedom. All right, so today, no school for Memorial Day, but the work still continues. We're actually going to power through this week, and this is our schedule for the week. Video, watch the science and engineering practices recorded, which is this one, and we're going to do science and engineering class practice 4 and 5, and then that's going to be due on Wednesday. And then, of course, SEP number 3 is due, which was from last week. And I posted an electric motor project check-in for you guys to answer. Are you going to do it? Are you going to just make a model? Are you going to make it work? That's my question for my check-in. Wednesday is, again, if you want to refer back to this recording, in order for you to do science and engineering practice 6, 7, and 8, please do so. And that is going to be due on Thursday. And then, again, I assume that you are continuing on working on your electric motor project. I've been asked by some of their classmates, what if they don't have any materials and all that? Please improvise.
What do you got around you? Use what you have. Yes,
it does. If last resort, I really don't have any materials, my parents didn't want me to go out, or we're having a hard time, please use whatever you have at home, because you are either going to build a model that's not working. All you need to do when you present it on Friday is for you to be able to explain the mechanism behind this DIY electric motor.
And remember, your model, it can be made out of found materials. Or Mrs. White, can they do a really nice drawing of a model also? Can that be a visual representation?
That could be.
Explain the parts and pieces and they diagram it with labels.
Yes.
I know some of you have some really great drawing skills and abilities.
Yeah. Again, improvise. Be creative. You're not limited to what I recommend for you to use. It would be great for you guys to try it out because we didn't have the chance to actually build it in the classroom, and which is why I would encourage you to try it on your own. Even if I'm not there, some of you would really go for it. But if not, show me an improvised version of your electric motor in however way you can. Friday, I will have you guys do your 8th grade science self-evaluation. This is just for you to recap the whole entire year that we spent together in science. Friday, we've gone a long way You guys have grown to be the best versions of yourself. So let's finish strong this week.
Celebrate and review it. I love it.
We are very proud of you guys. So what we've been learning, that is your science and engineering practice. We've knocked down 3 and we'll finish 5 more this week. It's going to be short, sweet, but straight to the point. But we're going to get going. We're going to go straight away to science and engineering practice number 4. And just looking back on our previous semester, we actually have practiced developing and using models when we made our planets. No, but there are different multiple representation of models when you develop them and when we actually use existing model. Even if it's just in an illustration or a 3D model, that goes along with this engineering practice. Some words that you guys will encounter when you do your science and engineering practice assignment for this week, we have models. So anything that we construct, claim something is a model. And when we try to look at the model, we evaluate or we try to determine the quality of the model, how well it works. Some model might be better than others. Some models might be something that needs some tweaking, but that's a part of developing and using models. So if you notice last semester, some of you guys used a balloon to make your planet. It kind of didn't work. Some of you guys were successful in using the balloon to shape your planet. Some are okay with like, okay, I'm just going to get a styrofoam ball, so that'll be easier. But then again, there are different ways on how you want to represent your project that you did in the past, and you are actually evaluating them. Systems. It's another word that is related to this science and engineering practice because we're trying to see how the interaction work seamlessly together to form a whole structure. An example of that is we made our model of the phases of the moon, for example, on how it actually replicated the phases of the moon. All right. And also simulation. It's an imitation or a mock version of a real world process. And that is actually the simulation we did in our virtual lab. Virtual labs on collisions. That is an example of a simulation. These are examples of the models that we may have encountered in the classroom. And I focused more on the science part of it, although there are different models that you can use in history, in English, in math, and PE even. There are different ways in how you can use and develop models in this space. So molecular model is one, layers of the earth is another. If you take a look at some simulation that we have done on our virtual labs, that's another example, as well as everybody's favorite, the exploding volcano with a baking soda and a vinegar. That's
yes.
Popular model. And of course, whenever you guys even play games, simulate, let's say a road, for example, from your computer, or even the games you play, that is another model that you use. And so let's take a look at some model. And I chose this model in action, which is the volcano. So what is the phenomenon this girl is modeling?
It looks like she's trying to simulate via a model what a volcanic eruption would look like or how it would impact the little village toy houses all around.
Yes, and of course, there are ways that she has simulated this model to the real thing by having the baking soda and vinegar react. So it'll start oozing down from the inside of her volcano model out of the volcano.
But I also like how she used different kinds of houses. Maybe the houses are made of different materials. Maybe the materials are impacted differently by the volcano. Maybe they're at different distances from the volcano.
And remember, going back to our definition of our model of what it means, it actually help us identify some patterns that we could detect when we use this model to explain a phenomenon. But in what ways is her model not like the real thing? So what do you think? Is it that kind of not like the real thing?
Lava is really hot.
Yeah.
So I'm thankful that her explosion doesn't have the exothermic reaction going on with the heat.
There's no smoke. There's no clouds of gas.
Oh, yeah. Pyroclastic flow.
Exactly. So that is not what is close to the real thing. So that is how we can use a model. Let's go to SEP number 5, engaging in an argument from evidence. And I'm sure some of you loves to argue, but this is a different argument. It has to be always based on evidence. And again, argument, the act of convincing someone or something by claim, sorry about the typo, by stating a claim and providing evidence. Again, stating a claim and providing evidence. Of course, the first part of your argument is a claim. It is an arguable statement or assertion that something is true. Now, evidence is the second part of your argument. Usually, you state the facts that helps prove a belief or suggestion. And of course, after your peer actually have heard your argument, then your peer may discuss this argument that you made and try to compare and contrast any evidence. Either you try to negotiate on an agreement about that argument, or your peer will completely say, yes, you made a point of that argument because your evidence is quite strong. So that's an argument. When we engage in an argument, arguments could start with a claim based on opinion. Okay, so an example of an opinion. Here's my example. I think the best way to increase our flight distance is to reduce weight. Okay, so that is an argument, and it starts with a claim. Another example, only the best predator use a venom. So that's another example of an argument that is based on opinion. Now, argument includes giving evidence. So if you start to kind of like putting a claim, you have to have evidence. So in this case, going to following the first part of your argument is because when we add weight to the wings before, the distance decreased by 10 feet. So that's the following part of your argument. Now, another example would be because they weigh 120 grams. I mean, it's not related to what I gave you on the first example, but that's another way of citing an argument that gives evidence. Now, let's continue to the third one. Arguments are meant to convince someone or something. So they're trying to convince, not to fool them, okay, but to actually try to lean in and say, okay, you have the evidence now, what else? So for example, you use some words as most effective, most accurate. So note though that opinionated words may be used to make the argument sound more persuasive, okay? So that's why I included most effective, accurate. There are other examples that you can say it's the precision of this device, for example, that those are some arguments that are meant to convince someone or something. And lastly, the fourth part of your argument is arguments are often formed from observable data. Okay, so to continue on, 10 feet is used in this example. This data is observable, measurable, and concrete. So these are observable data that would actually make your argument stronger. And also, you try to back up your evidence with data that makes your argument a strong type of argument that you present to others. Let's take a look at this data. So what's our evidence? So based on your data chart, formulate an evidence statement that supports this claim that Kara's paper airplane design is more efficient than Nick's paper airplane design. So let's take a look at our data. So that's our claim. What do you think is the evidence that supports this claim based on the data that we have? Okay, so think about that for a moment, and then let's try to draw some evidence. We are actually trying to make an argument, but we also use the data that we have in order for us to support the argument we're trying to make and support that claim based on the evidence on the data, which is why this is our evidence. Kara's airplane flew 25 feet, while Nick's paper airplane only flew about 18 feet. So the airplane that traveled longer distance would be considered more efficient. And if you notice at the end of my statement, more efficient, that is actually something that could persuade or convince, okay, the audience that our evidence, our claim, is supported by this evidence based on the data that we have on this chart. So that is, of course, using evidence to argue a fact or an observable fact that we see based on our experiment in this example. Now let's move on to, so SCP number 6 is obtaining evaluating, and communicating information. So if you notice, there's a lot of things going on, but we're going to take a look at that one by one. When we try to communicate or obtain data and try to evaluate the data or information to be valuable, of course, we have to find source first for obtaining some information. So it could be a person, a place, or a thing from which information is obtained. And of course, that source could be media, a particular method or means by which information is shared with others, and evaluating. Of course, if we try to find some information, we have to see if it is accurate, credible, see if there might be some bias in that information published that you are using. You don't want an information that is false, okay? Because when you present it out to others, your information must be reliable for others to use in the future, because potentially, for example, in science fair projects, okay, other students might want to replicate your study or your research, and therefore we have to present and communicate data or experiment or project that is accurate, credible, and they can use in the future.
Yep.
So where can we find information? So there are a lot of ways we can find information, but these are what I would recommend. Textbook. Of course, textbooks are written by experts and in specific subject. It can be any subjects, not just limited to science, but also other subject area. Another example of where we can find information is online resources like database, online encyclopedia, any resources that has .edu or .gov or .org websites could give us reliable information, and also some primary literature. So what does that mean? These are research papers, articles, and journals. Okay, not just in science. If you're interested with other subject areas, social sciences, that is a good way for we can find some primary literature that actually shows us information on whatever information we're trying to find based on,
Perfect.
yeah. So,
And with that too, to be mindful that your sources can also be primary source individual. So maybe you could talk to somebody who's actually been in a volcano. Hello. Or maybe talk to somebody who's been in a natural disaster before, or experienced snow, or seen a phenomena with their own eyes. Maybe they weren't there, but maybe their parents were. And so going to those first person sources, that's why I drew my little person with the talking symbol here. That's another source of information for you to speak and to gather information to increase your knowledge and your understanding of a topic.
Yes, it could be someone who is an expert on the field that you're trying to study. So that is another primary source of
expert or experience.
Some information that we can get out of different sources or media. So reference books. So these are some information that we can look for quick facts, statistics, or data. Those are reference books. Nonfiction books, of course, that's your textbooks. It can provide us some information, nonfiction textbooks. Science journals, these articles written by doctors, scholars, and experts, and of course that brings in new research in whatever field they are involved in. Audio and video, we can look at documentaries, History Channel, Discovery Channel, and also other media that provides us visuals and sounds about a phenomenon. Magazines are another way we can find some information. Usually these are current events, whatever field that might be. Magazines are the ones that usually print out and publish information that are current. And lastly, the website or search engines. These are digital collection of any web pages, multimedia, or content that is, of course, dedicated to a particular topic or purpose. So we start searching Google and stuff like that, and we can find vast of information if we use websites. So let us take a look at some of these media that you should use or maybe not use to find information. How do you know if the information is credible? This is an example of an activity. I wish I would have had the time to have you do this interactively, but I just wanted you to do this with me right now. Let's circle or cross out the ones that are not credible, but circle the ones that are. Let's start first with USDA.gov. What do you think is that? Is it credible or not credible?
I'm going to go with credible.
Let's take a look. It is credible.
Yes.
So, life science, credible. How about the PBS Science documentary?
I'm going to still go with credible because PBS, the public broadcasting system, seems pretty credible, and a documentary is documenting things that actually happened.
Exactly. That's right. And how about YouTube? But you know what? Some people would say it's helpful. I can find some tutorials and stuff like that. But then again, we have to see and think about how credible they are, which is why we can't really consider YouTube as a credible source. How about answers.com is another source that might not be credible, because these are kind of like a crowd sourcing type of website that has
open source database.
Yes, open for each and everyone's views and answers, so which is why it's not credible.
Of course, same with Google Image.
How about the National Science Review? That is actually a credible source. So this is a journal, okay? Wiki Answers. I know this. Some of us are pretty like, oh, I'm gonna find the answer, type it in Google, and then automatically some of the wiki answers are there. Unfortunately, this is not a credible source. And how about a newspaper article? What do you think, Ms. Watkins? But newspaper articles that might give them their view, like when we go back and give us an argument, they have a claim and they have their evidence, that could be a possible credible source. American Journal of Medicine.
A good source.
It is a good source because
I'm going to go with
yeah, exactly. How about Time Magazine? But it is a credible source. Encyclopedia, obviously, it's at the library.
I'm going to say yes. A hard yes.
How about an essay written by a friend? It's not a credible source. Obviously, science textbook, it is a reliable source. How about a blog site? Nope, it's not. How about Wikipedia? This is the most popular one that everybody was trying to use whenever they try to write. Even the informal research that I give out to my students, to you guys, I don't know, but it is not. They actually direct you to the source in itself, which is good. But
yes, they do.
Is not credible all the way through, because they also rely on factual sources, like the actual credible sources. Okay, so just to recap, how do you present information? So if we have obtained information, we also want to communicate our findings, especially if we are doing science fair project or research, even presentation in your classroom. Of course, we found resource. Just to recap, we look for source where we can get information from. And of course, if we're presenting to our community, what do you want to communicate to your audience? Who are your audience? And of course, what means of communication? How are you going to communicate that? And how will you make the info easy to understand? Well, that would depend on who your audience is going to be. And of course, are they going to be able to understand your presentation? And of course, be open to
being mindful of the audience. That's a good point, Mrs. White.
It matters of what mode or way you are going to communicate with this information that you might have. It can be a model. It could be a live experiment. It could be a slide presentation, a brochure, a video, just like what we're doing right now. And of course, it could be a poster. The poster board is actually the most common that we use in science fair projects. So that is our science and engineering practice in terms of obtaining and communicating our information. Now let's go to the next science and engineering practice, which is planning and carrying out investigation. Now, planning and carrying out investigation could be a part of a research that you can communicate based on what information we have obtained. And if we want to test that information, we can plan and carry out investigation. Now, some words that's used in investigation are these words: variables. During an investigation, some variables can be changed or kept the same. So that's when you have your control and experimental group, for example. You also have trials. Whenever you are trying to conduct investigation or an experiment, it is safe to say that we try to conduct multiple tests to get accurate results. One trial is
Yeah.
not enough in order for us to verify
Mm.
the accuracy of the results that we might get based on the test
Yeah.
that we're trying to make. When even prior to actually doing an investigation or an experiment, we have to plan first, and there is a series of steps that you have to follow. And the previous science and engineering practice that we learned last week is, of course, starting off with observing a phenomenon, and then we start asking questions. Then we start gathering materials and identify the variables if we are trying to prove something based on what we see, based on the evidence we have. We're trying to hypothesize and say maybe prove a hypothesis to be right or wrong. And then we carry out investigation where we conduct trials, gather data, and draw conclusions. And if there's a need for us to repeat the investigation to verify the accuracy of our results, then that is usually what our scientists use and do in order for their research to be deemed valid. And if you are thinking about
Yeah.
in the science community, it has to be evaluated by other experts and scientists before it can actually be deemed to be something that could be a new
Yeah.
research that could be added in the future. Even those theories and laws that we have currently, theory of evolution, laws of motion, scientists, physicists, or experts actually evaluate those theories and laws,
Continually.
and continuously they've been, but once it becomes a law, you can't really contest that theory. Though you can try to prove it wrong, but it takes years and years and years to prove a
Yeah.
theory wrong. That's why it becomes a theory, because if you want, there's always a bigger chance for it to be a reliable um, research or study. So let's take a look at this example. What investigation do you think is worth conducting based on this image? What do you think is worth investigating based on this image? So I think when we discussed for seventh graders that we have, Mrs. Watkins, we tried to take a look at the properties of water, right? And it is something
Yes, we were.
that we wanted to find. It could be how many drops can a penny's surface would be able to handle.
Mhm.
And of course, if that is something that's forming into your mind in order for you to want to investigate them, then of course you want to think about the next step, which is to what materials do you need? So we already see
Mhm.
on our setup that we need water, we need a dropper, and of course we need the penny. We, again, when we try to carry out an investigation, we want to test our investigation more than once in order for us to do accurate,
Yeah.
to get accurate results. And let's take a look at some examples here. We are down to one more science and engineering practice, but these are some examples that I want you to think about. We're not going to get to this together, but I want you to think about these setup or investigations. So it always starts with a question. Will the food I eat on the top right side, will the food I eat affect my heart rate? So in order for you to try to see and answer that kind of question, you might want to investigate. Maybe for 1 week, Gary ate a balanced diet, and the following week he ate only fast food, just like the supersize me, and try to see,
Like fast. Oh.
yeah, and try to see his heart rate and how food affect his heart rate. The second one, does the type of sports ball affect how high it will bounce? Now, this is a good example that you can actually carry out investigation on your own. And lastly, what effect does air exposure have on the rate of molding fruit? So you might have some fruit lying around and nobody's eating it. Then you might want to investigate on placing that fruit inside a Ziploc bag and try to see what results
Ooh.
could arrive and we could find in this test. And lastly, we have SEP number 8. Not everybody loves math, but math is a very integral part of science and computational.
It's a wonderful thing, you guys. Math is a wonderful thing if you've seen School of Rock. And if you haven't, go watch it.
Exactly. And of course, what ties in with mathematical and computational thinking, you always talk about units. These are quantity as a standard measurement. We learned about Newton force, meters per second for speed. You have grams to measure mass. We measured mass in our weighing scale on our digital scale that we have in school. We also measure gallons for liquids, and of course meters per second squared for acceleration. These are units. And also mathematics.
And time.
Yeah, time is another.
Time. Hours, minutes, seconds, milliseconds, weeks, days, months,
units of
years
that you can use that is, of course, tied up to mathematics. Same with operations. Plus, minus, divide, multiply. So we add, multiply, subtract, and divide to solve a problem. And that is always tied up with mathematics and computational thinking, as well as quantitative words that such as quantitative. So we're trying to describe exact amount of something by using numbers. So we use numbers. Okay, numbers will give us exact visual of what we're trying to figure out. And lastly, of course, another word would be computation. When we try to calculate math problems through the use of calculator or computer, we are actually computing. Okay, now let's take a look at this example. This is just one example how we can use math and computational thinking in biology. So let's take a look. How would you describe the rate at which cells divide? So 6th grade, we learned cells. Okay, so if we start off with one cell at stage 1, once it enters stage 2, there are now 2 cells. Ooh. Once we get to step 3, we get 4 cells. So we cells divide and there's 4. Okay, and then by step number 4, we produce. Yeah. So if you could show this trend as a formula equation, how would you write it? And what do you think results into this? So let's take a look at the numbers.
I'm not going to show my answer yet.
From one stage to another. So it actually kind of compounded. So we can see some patterns. And by the time we reach stage number 5, there are now 16. We are getting a pattern, correct?
Yes, ma'am.
What pattern is happening? What pattern can we observe in this stages when cells divide? In stage 10, 512. So we are actually practicing some computational thinking as soon as we see some patterns in this setup or scenario that we have. And the number of cells that we see here appears to be doubling at every stage. And we saw that pattern early on. Now, this means that not only cells are increasing, but their rate is also increasing. And this is actually related to the patterns that we see in COVID-19, right? And called exponential growth. So in math, when you go to your math classes, they call it exponential growth. We make sense of what exponential growth means by looking at some examples that we observe in nature, what we observe in cell division, and that is your math and computational thinking. And where else can we actually use mathematics and computational thinking? We can use it in physics, we can use it in engineering, chemistry, geology, environmental science, of course. There's environmental physics, and then astronomy, and a whole lot more. Isaac Newton tried to say, okay, an apple fell on my head, and that starts with an idea, and that idea can actually be explained using math. Then he proved this point about the laws of motion, of proving that F is equal to ma, and that equation in itself is math, and that math supports his law that yes, if you increase the mass of an object with an equal amount of force, the acceleration would decrease because I did the math.
Proportionally. Yep.
This week, just to recap, and I'm sure you've seen a lot of information that you will find it useful when you do your science and engineering practice that that I've explained. So please make sure that you go back to this recording in order for you to answer science and engineering practice 4 and 5, which is due on Wednesday. It's already up and posted on Google Classroom. I also have the check-in for your project that's due tomorrow. Not tomorrow. Yeah, tomorrow. That's right, Tuesday. And then science and engineering practices 6, 7, and 8. That'll be posted tomorrow as well, but it's not due until Thursday. Now, the last piece of requirement that you need to turn in would be your electric motor project and your 8th grade science evaluation form, which is due on Friday. No extension, unfortunately, because we are going to finish up our grade and turn in our grade. So, Mrs. Watkins, you have anything more to say? Thank you for joining me today.
Oh man, it's so fun to join you. I am really excited. I'm looking forward to finishing this year strong like we talked about. And if you guys have any questions, please feel free to let us know. We're available via email.
Please send us and send me a message if you have any questions on the assignments throughout the week. Thank you so much for listening, and I hope I'll be helpful
Remember,
throughout the week.
you matter.
Yes, you matter. And the speed of light, which is easy.